Thank you, Matthew, for the introduction, and I will go straight forward really to my slides and introduce myself. Good evening to everyone. My name is Jamal Alabid. I am Assistant Professor in Artificial Technology, working for University of Bradford. But what brought me to this webinar really is my expertise in retrofitting. So I'm BAS 2035 retrofit coordinator, so qualified coordinator. And also before that, I was certified as passive house designer. So the webinar topic for today is the BAS 2035 for retrofitting domestic buildings. And that's just to clarify, 38 is the non-domestic buildings. So the outline for today's webinar is we're going to look at an overview really on the process and this document and what it brought to the industry, especially aligned with the net zero carbon target, and also a bit of context and background on the this document when it came out and why as well, and worth looking at the significance of following this document as well. So looking at unintended consequences, we're referring to quite famous case really, Preston case, and looking at the rules that are defined by the BAS 2035, including assessors and coordinators and designers. So looking at how this procedure really deal with the retrofitting projects, including how to define the risk paths. That's the first really probably step, looking at this document. And then finally, just probably here, this digital technologies, how really support the target, the net zero carbon for retrofitting buildings. What technologies that are probably appropriate to understand and worth looking at with with aligning with that, with the retrofitting projects here. So that will be covered in part 2, another webinar, because it's just more practical really, looking at a few technologies and softwares that should be used when we're looking at retrofitting buildings. This is just looking at a few documents, including the BAS 2035, and luckily last year it wasn't free, but from last year and it's still available free, can be downloaded, and also the compliance as well document, which is now free as well. So all of these are funded now and available for public. So worth giving the link later when we share the slides. You should be able to download these documents. So what is BAS and what it refers to, and whether it's a new standard or a new framework. So understanding what is exactly this document and what leads to is vital really. The publicity available specification, that's what it stands for, which is, I would say, a framework or a guidance that refers to various standards, including the BSI, British Standard Institute standard, and others really, not just that standard. So how you comply with this using this procedure. So it's more kind of managing the retrofitting projects here. And going back a bit of context on this, where it came is and why it was out. This document is because of the each home council review that happens in 2015, not 5, to 2015. The Bridge Research Establishment as well review area than that, really. They mentioned this, the need of a specific like standard, but this is not a standard really that came out, is a framework I'm referring to again. So the British Standard Institute standard looked at this with collaboration with other professionals from other, like AACB, which is the Association of Environment Conscious Building, and also CIOB, the Chartered Institute of Buildings, BBA, which is the probably the largest professional body for accreditation, stands for British Board of Agreements, I believe. So it was really a response to the call from the Each Home Council review in 2015. Sorry, I'm again mixing up. But why it came to came out is because of the retrofitting projects that earlier than that date shows a quite significant failure, I would say, in this context, especially for pre-1919s buildings. We refer to the solid walls here. So there was a lot of problems related to mainly related to really health problems, and also technical things really went wrong. The Preston case study will show probably an example, good example really, to demonstrate the unintended consequences, and showed that probably one measure and shallow retrofit schemes were not appropriate as well. And also when it comes to accountability, who is accountable for this unintended consequences and the issues that caused by retrofitting buildings, and why the design was poor. Is it lack of professionalism? Is it lack of management? So there is a gap really, in just not in performance gap, but there is a gap of understanding the procedure. So it was really a good idea to get a document that really guides people throughout the retrofitting process or retrofitting projects. I'm just trying to define myself the retrofitting as not just renovation or refurbishment, because it's interrelated and it's interlinked. These terminology: renovation, restoration, refurbishment, but the one that refers to improvement of energy and thermal performance of the buildings that leads to reduce, of course, the carbon emissions, that's what we mean in this context by retrofitting, as refurbishment can be just an aesthetical really aspect, so changing the color, changing the painting, tiles, but that might not really lead to an improvement of energy or thermal performance. Of course, environmental performance is counted here. So that's where we really distinguish between retrofitting in this context and renovation, restoration. Restoration probably is quite clear. So restoring that the heritage of the building. Probably this flow chart with this diagram is not clear, but is defining stages from the assessment to the design to the commissioning and handover process here. I'm just referring to a couple of steps or few steps here where first we call it retrofit advisor. He could be the designer, could be the person or the coordinator, the person who has the knowledge to, or technical knowledge to advise the client and have or has more understanding of the intended outcomes. So it's kind of it's not an agreement, but clarification of what the outcomes expected, or not expected really, what the client exactly wanted to. Is it achievement goal, reducing the energy bills? Is it something reducing the carbon emissions? Is something? So what exactly the intended outcomes with the discussion with the client? Then again, defining the risk assessment, whether the building is path A or B or C is the other step, or the next step, sorry. And that will determine really the remaining steps. If it's path A, then even appointing the assessor will be quite different from having a path B or C. We will look at what we mean by this in a few minutes. So then, yeah, the third step is looking at the dwelling assessment itself. So assessing the fabric, assessing the occupancy, assessing what else here, assessing even the surrounding, if it's path B or C. So where the improvement can happen. So assessing the building and around the building as well, including the fabric, what exactly, whether it's breathable or not, whether it's, so defining this and understanding this will give really clear idea to the designer to deal with that improvement. And step 4 is planning and designing. So this will depend on the first 3 steps. So how to plan this and how to design the improvements, whether it's related to fabric, whether it's related to system control, will really depend on the assessment. Accurate assessment will lead to good design, really. And probably the diagram, I can't probably, I don't know if I can zoom in, but this is when you define the path, then you go to that option, to the third one. So which is the far right end, and where a professional body or person will be there. So someone, let's say, even assessor, someone understanding and has a technical knowledge of traditional buildings, heritage buildings, and the way the fabric is need more, let's say, carefully really treated in this way. Let's move to the other stages here. So the 5th stage is bringing a certified installer here. This is where it comes to the Retrofit coordinator to manage these things, and especially the new update. I should have mentioned this. The one that we're looking at, and the current document, BAS 2035, is the 2019 version. So there's another update will be released next year. That's same BAS 2035, but is a version of 2023. Well, it started last year, but it will be released. Really specify a lot of rules during, especially the installation and handover, and also for the retrofit coordinator intervention and accountability on this stage. This stage, stage 6, is the monitoring and evaluation stage. Now this will define, the time and the period the building should be evaluated or monitored, sorry, and who accountable for this time as well. So there's 3 evaluation stages, whether it's basic or advanced evaluation. So it can go up to 1 year, starting from 3 months to 1 year. Monitoring depends on the certificate that produced earlier during the installation. So this is probably the final stage, but the retrofit manager or coordinator is the one that needs to look at all of these stages and oversee all these steps from A to Z, and the accountability goes to that person really. So the new BAS 2035, we're referring to the domestic buildings, very similar and almost quite similar really procedure for non-domestic buildings, the 2038. But this document defines a few rules within this procedure, let's say. So this introduced 2019, including the retrofit advisor, which is a person has the knowledge really to advise on the intended outcomes. So what exactly understanding the client requirements and the project requirements as well. So there's a limitation and there is a scope of each project. Retrofit coordinator, so that's a qualified person who had level 5 diploma in retrofit coordination risk management, and also being registered with a or a chartered member with the you will see this on the next slide probably, a chartered member of ARB, COB, CIAT as well. So a few professional bodies that this person is accepted. Retrofit assessor, it could be the same as retrofit coordinator, apart from the Path C. Now there's another rule for that retrofit assessor who had the level 3 qualification. It's quite useful really, this qualification. And by the way, probably I will put links to a few fully funded courses for this level 2, level 3, level 4 qualifications in retrofitting, including the older and traditional buildings. So it's someone who is qualified to assess Path C. Well, installers and especially the fifth step, that were the installation and handover. So they have to comply with BAS 2030 for it's mandatory. Well, probably we forgot to mention that is mandatory for funded schemes, not for private at the moment. Hopefully in the future that would be including even private schemes. So yeah, retrofit installer, so he's a qualified and certified installer. Again, retrofit designer, someone has a qualification in architecture, in building surveyor, what else? We will look at the qualification that needs to be for retrofit designer. Retrofit evaluator, so that comes later in stage 6. So it could be the retrofit coordinator, but some cases it has to be an external retrofit coordinator if the evaluation is advanced evaluation. So it's not allowed to for the retrofit coordinator that appointed for that project to go for that stage. Apart from that, probably well, this is the one that I wanted to show with you, to share with you, sorry, is the rule that's defined earlier here, and what the description of that rule, what the person is qualified or can do within that process, and the qualification. So if we look at retrofit assessor, for example, someone had a qualification of that level 5 diploma retrofit coordination. So that would be enough for path A, risk path A. But for and domestic energy assessor for path P and C but also they have to have this qualification level 3 for traditional buildings, the one that I referred to earlier, and then registered with a accredited professional body like Elmahas, Stroma, and a few more really, not only these two accredited bodies here. Coordinator, again, someone has the level 5 diploma as well, but also has an experience in the profession. So including these rules here, and registered with this as a qualified member, and registered with this schemes, Trustmark schemes. Trustmark scheme came as part of this really framework, because lots of problem is that with industry, especially with the clients, they lost really the trust with without having accredited or a Trustmark scheme. Installer, again, someone understanding the BAS 2030 and certified installer as well. Evaluator, again, as I said earlier, could be the retrofit coordinator himself or herself, but in some cases, probably not mentioned here, an external evaluator has to be appointed if something went wrong, and advanced evaluation is required. Okay, probably this is an overview, not overview, but it's just showing why Trustmark scheme has to be there, and in this scheme, on this process, 9% of this, especially before 2013, data showed that measures were not fitted correctly. There's a lot of failure, a lot of technical issues, a lot of problems. Again, the Preston case will show a few examples, but the main thing is that the market start really losing the trust of the whoever delivering this project, started really losing the trust with this. So there must be a body, professional or accredited body, like to ensure the quality is met and with compliance with this. So this will be also in coordination with the retrofit coordinator. Yeah, so this is what. So looking at a Preston case here in specific, I'm putting a link with this slides here for that social housing and what went wrong exactly. And Kate Henderson, if I still remember, the one that was in charge of this project. So lots of issues. These photos were taken from these houses, and you can see how terrible really the situation, the mold growth and damp everywhere. And not only that, it led to big really complaint by the tenants. So some of the unintended consequences of this were the ceiling collapsed, health problems, and one was hospitalized and got really long health issue. So even the installer faced a big finance, really big fine for this. And as Kate Henderson mentioned, that getting everything back cost about £6 million. just to really retrofit these social housing back. So intended outcomes can be avoided earlier during not the design, during the assessment really, understanding the fabric, understanding probably not just the fabric. So the way that the building is used as well is will have a big impact on the health of the building and the occupants as well, and how many people using that the building, and even the type of the building, whether it's social house or so it has different occupancy patterns. So of course we probably all understand. So the headache and the problem is that if things like went wrong, how are you going to get this back? Time consuming, cost, and a lot of disruption as well. So this case study brought really awareness of how retrofitting should be really carefully treated and dealt with from the beginning, and understood well really from the beginning. So, but what possible, let's say, reasons behind this is not really probably properly understanding the climate conditions around the building, whether it's heavily exposed to wind or rain, or so the conditions around the building. The assessment wasn't really accurate, let's say. The one who did the assessment, well, it's clearly that is a building assessor, so energy assessors, but they lack of knowledge on older buildings and traditional buildings. So that them not really understanding the behavior of the fabric, whether it's breathable or unbreathable, and how to introduce a new material and how that works together. And this is, by the way, when we look at software like Wavy software, will give you really a good understanding of how materials work together as assembly, and how to avoid especially moisture issues in especially that trapped inside the fabric. Poor design and detailing, and that's of course because of lacking of understanding of the building fabric, and probably including the thermal bridges here and how openings were improved or changed. If let's say changing the window with a doubly glazed, and the internal surface temperature factor increased because of that, that spacers that introduce it, the metal one, the aluminum one, that will increase the conductivity and will create an issue around the buildings, and cold bridges we refer to. So increased relative humidity here. Now we're referring to, well, the building probably more sealed, so airtight, but not proper ventilation was, designed for the building. So not always like mechanical ventilation is the best option or the first option, but we need to understand how the building is now, how leaky the building is, and what the appropriate ventilation system could be introduced to the building. Probably installation and workmanship that during the construction and during the installation of systems maybe was poor, and wasn't adequately sealed and may allow rain penetration. So it could be one of these reasons really. So this is the highest risk is getting your building damped with water content, whether it's penetrating through the fabric, the external walls, from the ground, so this is where water get trapped there, can cause a lot of problems, of course. So earlier we referred to the step 1, so the compliance document, which is now available really for public to download free. The first step is to define the intended outcomes. So it's a discussion with the client and identifying a few options here. So what the reason for improving the building, whether is the air is like it's not the air quality, the indoor air quality is not sufficient. So probably looking at improving that. Whether it's a risk of overheating, the building could be get overheated during the summer. So identifying few options will really lead to the next step, where you can plan well and design well according to these intended outcomes, or what the client exactly wanted to simply the measures really, the improvement measures that should be taken, and whether which software probably you're going to use, whether it's SAP or PHPP, which is the passive house it's like a tool that they use, but it's not the PHPP, it's the Interfit standard. So REB, if I remember well, which is the passive house Interfit standard. That's for existing buildings. PHPP is used for new built homes. So it's defining earlier these intended outcomes. It comes earlier. I think we mentioned the rule, but we didn't mention where exactly, at which stage this person is qualified to carry out that task. So if we look at the 3 paths, which is the second step, really, to define the path risk, if it's low or medium or high, we will mention later, or look at where is path C especially is defined. But looking at which path risk is defined area, then who is qualified to carry that task during the assessment, during the planning, during the design and installation, and so on and so on. So this, by the way, is slightly changed in the new update, especially for coordinator intervention during the medium and high, which is path C. But it's not major change really for the new update, which is 2023. But it's clearly really defined at which stage who is qualified. For example, in design stage at path C risk, path P, sorry, a coordinator or designer, but path C should be a qualified person as a designer, unless the coordinator himself or herself is a qualified designer for older buildings, let's say, or traditional buildings, and so on and so on, till you see that monitoring evaluation stage. Again, the last one usually is an external evaluator, as a coordinator, but not the project, the one who's carrying the project or managing the project. Right. So what is the exactly the retrofit coordinator, which is could be referred to the manager, the project manager in this procedure, who's the person that qualified, again, who had a level 5 qualification and chartered member of those professional bodies that we referred earlier to. So qualified to carry out or oversee the whole process, including the planning and advising earlier, and then depends on his and her qualification again to carry out to the last stage. Risk assessment again, is few steps to define whether the building is path A or C. So the number of projects, the number of dwellings or buildings, and the age. If it's traditional, then so let's just see if it's 1 to 2 dwellings and it's not traditional building, then going to be risk A. So not really high risk. If those buildings, 11 buildings or units or flats to 30, unless it's heritage building, then going to be path B. Whenever is traditional buildings, even one building, then it's going to be C. So traditional buildings, older buildings, that will affect the whole risk assessment, and it immediately will go to the risk or path risk C. So another thing is how many measures that being agreed on the intended outcomes. If it is 1 or 2 measures, then it's going to be path A. If it's more than between 3 to 5, then B. So considering that the previous category or criteria, which is the number of the buildings, and then I think I mentioned already the type of the building, the typology, whether it's traditional or non-traditional, let's say. So the combination of measures, the metric will show this later as well. So you see where there is like kind of a clash, really. So it's like the refer here is to the inherited technical measures here. It's an interaction of multiple or combined measures here. What else here probably worth mention? Yeah, so this is probably that the last one is the building typology also. And again, there is another element here, whether the building is low-rise or high-rise building. Protected, we're referring to the traditional buildings or heritage buildings. Any building that fails into this category. Well, this is really interesting, which is part of the compliance document. So the interaction metric here. So you can see same measures on the diagonal side and the top one, but whenever there is inherited technical issue, that will flag up on the red side there, and you can select the number of measures there, and on the right column, it's not showing here, but will show the inherited technical risk. So whether there's 1, 2, 3, 4, or so probably here it shows in that column, but even with the metric would show. So whether it's 3 or 1 or 4, or will show on that metric or interaction metric. Matrix, sorry. So by selecting the measures that intended to carry or to improve, then we show whether, as an example, for example, if it's changing the boiler and let's say changing the ventilation system. So whatever that measure that has a clash with another building will show whether it's safe, green, or a little bit needs more details. But red is not allowed, and between the green and red is where needs more details, or the amber one needs a certificate, really, and the yellow one needs more details for the installer, so to understand exactly which one depending on another one, which one comes first. But the amber one, which is the third, needs certificate, so official certificate from the installer to carry out this task. Red is not allowed at all. The triaging risk is this is where you put all of these measures here, the typology of the building, the size, and this, and then we'll come up with that path A or C or B. And that will take you to the next step. So the risk path A or B or C determines the project management approach. This will be decided by the retrofit coordinator. I think I did explain what path A really is. Is quite straightforward and has less or no risk at the building or the measures to be installed. Path B needs deeper understanding by the assessor, by the professional, by the designer, and medium-term plan is mandatory, which is we're referring to 15, 20 years plan. Path C, of course, that's requires deeper understanding as well of assessment, and for example, the air tightness impact on the building, whether will change the behavior of the fabric. If it's breathable, let's say, then that will cause problem really. Most of, or not, probably all of traditional buildings, they are breathable fabric. So installing air tightness, that would cause a problem. Of course, yeah, change the behavior of the fabric. Step 3, so the dwelling assessment, which is that that requires whether it's energy assessor or retrofit assessor. Retrofit assessor, who the person who should have already domestic energy assessor qualification, but also had the training to be retrofit assessor. So it comes from really every building probably has, even if it's a typically same as typology, as size, but it has probably the building from same building, they will have different orientation, exposure, occupancy history. So every building should be treated really as a specific or a different case. The person who carry out this will have or meet the requirements that defined or set by the retrofit coordinator. Is the one should be advised the client and had the understanding of the intended outcomes. So they will, this is which is earlier stage, was the first stage. Then the assessment will follow this, but we'll get the advice from the retrofit coordinator. Again, the risk assessment path will determine really the type of assessment, as I mentioned it, whether it's requiring a retrofit assessor or just DEA, if path A or C, so path A or B. So the type of path will determine the level of work needed, and whether at each stage certificate will be provided or not. Path A, I think we mentioned exactly as how low risk, almost low risk, yeah, always defined as a low risk, and not less care needed, but no deep understanding and probably care of ventilation and this, because one measure wouldn't really have that much of impact, let's say, on the other measures. If you're just changing boiler or windows or whatever, it helps improving the thermal and energy, but will have less impact on the building. But if 3-5 measures, that could be a clash or an interaction between measures, then we will look at other measures, how they are impacted. So in this path defects and repair is required mostly, and to get to the condition to avoid any hidden issues people can't see, but probably with tools like this, dampness like tools that measure the moisture content within the elements, whether it's concrete or timber. So it's a few things that need really to be detected earlier, even if one measure is installed. Looking at the existing windows and doors and their performance is also is really something worth to look at, even path A. So using the RD SAP assessment tool will help somehow, but honestly, I've used this tool and can see probably lots of things that out of control the assessor or the one who is using this tool. Lots of default data like occupancy, typology, and it's reduced. I know it's reduced to do the job quicker, but the input data is limited, and that's probably one of the issues using this tool here. Well, this tool or full SAP will calculate the U values, but always worth checking the accuracy of this by any other method to validate this. So probably these are the main elements that probably need to be considered in path A. Path B, so everything that mentioned earlier, but a proper assessment of the occupancy, especially the history of that will really determine if there was a high risk of moisture, let's say, trapped somewhere, and how deep this assessment should be. And also who are using this building, if they have a special like consideration, let's say, and they need to be identified earlier. The ventilation or proper the existing ventilation and the introduced method would be also identified to avoid any dampness or condensation in the future. So we will look at these two types here: the mechanical ventilation with heat recovery system, or the extract ventilation, which is probably very common in many buildings. Path C, so everything that considered earlier, but here using any elements like air tightness, membrane, or element here will be really carefully considered here and understood, and should be done by someone has the knowledge and experience to understand the impact and the implication of using air tightness, getting your building sealed. Surveys as well has to be done by a qualified person who has level 3 qualification. Really, I advise anyone who interested in retrofitting to get this qualification. It's a few weeks, let's say 3-4 weeks really takes maximum, but really give you an understanding of different typology, different ages of the buildings, like Edwardian, Georgian, Victorian, and it's not just the characteristics of the building. And the characteristic of the building probably and the features of the building is important to recognize what the building, but also you can identify whether there is a change happening by understanding the type of the building, and also the material and the fabric, the envelope, the external, especially the floors. So different materials used in different era. It's really worth understanding lots of technical and history about the buildings when you take this qualification. I had it myself December last year, quite recently, but really helped me understanding a lot of things about the heritage buildings. So defects based on inspection, and again, it should be someone who had this qualification to do this. So looking at the heritage buildings really, and the old buildings, old and traditional buildings. Make general recommendation in respect of the priority and likely time scale of necessary work. So that with understanding the building typology and age, yeah, you can identify it's not accurate time scale, but a proposed time scale, and you know how that will take time really. The legal implications here of the ownership should be identified and clearly declared as well. Who is taking the responsibility? Of course, there's a planning permission area, and of course, there's like a professional insurance. Agree or not that 2 years ago, I had an experience with this, but like these creditor schemes like Stroma, I just went straight to Stroma to get this insurance, and they put me through a third party, and just a discussion like those people, they think that everyone is understanding the legal, terminology, the legal things. So to be safe, really, just include everything. For this discussion is all, unless you are someone who understanding the legal aspects. But I thought this discussion is just a waste of time. So you go just really straightforward to that, to cover everything, including personal insurance and what they call liability, and so to cover everything really. If you are a qualified retrofit coordinator, your insurance should cover everything. Ventilation assessment. Now this is probably the most problem that's known, and the issue that probably everyone like worrying about is the ventilation. So improving the fabric, improving the system, whatever, that will have an impact on the quality of the air inside. Most of our buildings here in the UK quite leaky, so very rare to see a building hasn't been improved. Will achieve like an air change per hour like less than 10. So they're quite leaky. But when you do an improvement, adding insulation, adding air tightness, that could lower the infiltration rate to really low rate, and then will have an implication on the indoor air quality. Most heating season nobody will intend to open the windows really. So that's an issue really. Will create unhealthy buildings, not just occupants like health issues, but buildings can get sick, and that will turn to the users of the buildings. So defining the appropriate ventilation system, that will depend on the improvement and the infiltration rate. So it's always advised to take like this quite known test, the door blower test, yeah, to see the air change per hour. And if it's less than 5, then yeah, you could introduce an efficient system like mechanical ventilation combined with heat recovery system. So this system, apart from it's quite efficient, it can achieve almost 96 or 97% efficiency, but also introduce fresher air. So this is the advantage of this system. But if the building is quite leaky, then you won't really have this advantage of keeping the or recovering the heat really. So it depends on the level of improvement and the measures that's been installed. You can really propose what appropriate ventilation system, and that's not just looking at the health of the people, but also how you can avoid any moisture that trapped or accumulated within time, even inside furniture, inside buildings, inside the internal surface, say inside roof. So that will avoid really the moisture, especially. Ventilation is a critical. Understanding every system, its advantage, it is drawbacks, let's say. So it is vital and significant in the process. Understanding how the technology helps is another. I need to look at my time. I'm not sure if I'm keeping the webinar within 1 hour, and this is my target really. A few slides left, but I'm looking at also this side of technology, but we'll expand on this for part 2 next time. But it's just worth looking at recommended tools, energy tools, like SAP, the standard assessment procedure. So this uses the methodology of PREDIEM, which is the energy assessing tool. So the other one is the simplified or reduced SAP, which is tend to be for existing buildings, mainly because of the reduced data by default. So it's more or less really input in RD SAP. So you could really use SAP as well, full SAP version for existing buildings. But the reduced SAP will do the job quicker really and easier. PHPP requires more input data, but to me is worth using this tool, looking at other elements like the costs, the carbon cost effectiveness, and a few other elements that worth really including in your assessment. So this is a design assessment tool rather than design really. Will assess your energy improvement and carbon savings as well. Again, as I said, PHPP would be used initially, then you export the data from PHPP to the Interfit standard to get the medium plan, term plan, sorry, and it's like giving a plan for like 20 years, 25 years, the improvements, and gives you really an options of selecting which one will, which measure will have more impact over time and also area, so you can decide where measures or where the improvements can be installed earlier. This tools here helps really the design stage, I would say, especially the Wi-Fi. So understanding, if I would use Wi-Fi with PHPP, I would use Wi-Fi passive It's just because it's integrated with a PHPP and Design PH tool. Design PH tool is a plugin used in SketchUp, but it's quite useful when you define the thermal bridges, the thermal envelope. Also, you can see the renewable options here, solar shading options here. You can define this in a 3D model, and you import this to, well, all the thermal elements, including windows, doors, and floors, and so all they can be specified using this plugin. And then you can export this to Wi-Fi passive to carry out the hygrothermal analysis, where is the heat that impact on moisture transfer within the fabric, let's say. So it gives you an estimation of how the fabric or the moisture behavior in the fabric over time of 5 years, 10 years. It's quite accurate, really. We tried this tool in a few projects in Scotland, and we monitored this. We measured the moisture content over time. We bought even sensors. We call them S2 type sensors that can transfer wirelessly data. So inside the fabric, inside the walls, inside, and gives you hourly, even sub-hourly data about the moisture content and the thermal behavior. So recording temperature, recording moisture content over time, just to validate the software results. Okay, PHPP tool is the passive house design tool designed to. And as I said, we will look at this probably in more details in part 2. Dwelling assessment, stage 3. I think we mentioned this, didn't we? Is that a mistake or? Retrofit qualification and training. I would recommend really having retrofitting qualification, starting with level 2 and level 3 and level 4, and also level 5 for retrofit coordination. It's worth really looking at this. I will put link to some of the funded, including this level 4 award in domestic retrofit assessment, and also level 3 is fully funded as well. Well, I'm not going to talk that much about this, but this social housing in Nottingham was a good case to see the management strategy that the energy sponge model applied there, and the challenge and limitation. And one of the challenges probably is clearly can see where one of the owners decided not to or agree to retrofit the house. This will have an implication on the other improved houses. Of course, everything is linked, roof, party walls, and so this is a challenge as well. But there is still very good outcomes came from this project, the social housings in Nottingham. Planning and design. So this will depend on the previous stages again. So the accuracy of the assessment and what intended outcomes earlier. And so you can have a plan, medium-term plan. This is mandatory for Pass C and B as well, B and C, but it's not mandatory for A, because it will have less really risk and less impact on the thermal and moisture behavior of the building. Yeah, within the compliance document, you will see options like this. So the evaluation options, and you can see both option 1 and 2 at the same time, And once you generate the assessment, the evaluation will give you really a data and results looking at not just energy savings, but also other elements like carbon cost effectiveness, and the cost of operational energy, and payback period. Period, how many years that's well. So we will have a few columns extra that shows your results and your implication. Well, payback period is not the best probably method to use, but it gives you really simple calculation of how many years that will take. Is it 1 hour,
Jamal,
Matthew?
Yes, yeah, we've gone over slightly actually, but
Really?
how are you doing on slides?
It's probably 2 or 3 really slides.
Okay, I'll let you finish them.
I will
We've got
finish
a couple of
really
questions
within a few minutes, really, with a few 3 minutes, 4 minutes, 3 minutes. Okay. I would say not more than 3 minutes. Oh, is it so? The medium term plan for PASI and PNC, we see that from the existing buildings. So how this will have an impact if you install more measures, for example, over that time. So it depends on the lifetime span of the building elements, windows, fabric, insulation. So that will have an average of 20 years or 25 years, and you see the improvements. Installation, of course, depends on the path risk. You need a certified installer, and certification or not, that will be determined by the risk path really earlier. Monitoring, as again I said, an evaluation that will be carried by evaluator, who could be the Retrofit coordinator, but in just a few cases will be not allowed for the same Retrofit coordinator or the manager to carry out the evaluation if the risk is high or the evaluation is advanced. Yeah, so these are the 3 evaluation stages. I'm not going to read them out, but it can be basic, medium, and high or advanced monitoring. Requires even up to 2 years, I think, not just 1 year. As a summary, again, I'm trying to summarize the webinar. The Retrofit coordinator role here is crucial, is really critical in the process, and the more that person, he or she, experienced in Retrofit projects, that will help really, making that the retrofitting process smooth. I would say we have already covered the steps, intended outcomes to the evaluation stage. Various actors are involved in retrofitting projects. So we look at the rules and probably at which stage and according to which path exactly. We need to learn from our mistakes. That's absolutely acceptable, but we shouldn't really repeat the same mistake again and again. It's worth looking at bad experience more than good experience to get lessons. I will stop here really. I will provide even links to few of these available fully funded or partly funded training and courses should be found with the slides that will be shared later. I will stop here, Matthew, sorry, and I will let you read out the questions, or if someone happy to just unmute.
Yep, I'll read them out and then you can respond. And I think looking at the questions so far, I've probably got a few things to say myself as well, actually, because it crosses into my domain as well. But anyway, thank you very much for part 1. we'll go through the questions that we've got. So we've got Richard Clark has asked, would you ever suggest just MVHR only, as insulation may be impractical or even detrimental?
MVHR, again, I think I mentioned something about this, is with combining heat recovery system, unless the building is airtighted to a level like less than 5 air exchange per hour, so an infiltration rate, exfiltration and infiltration rate is low, then you lose the advantage of keeping the heat, recovering the heat, really. And depends on the scale. The larger the scale, if it is small flat, then the system won't be really efficient as a larger scale. Let's say if it's commercial building. So the smaller the scale, the efficiency will be not the same, really. I know that control of air tightness will be easier for smaller scale buildings. So there is really compromisation, but the main point is for this system is to recover the heat. If you have leaky building, then you lose that advantage. So you're probably ending up with the efficiency will drop down, because you look at the input, the output, isn't it? The output.
I agree. The energetic benefits that you would normally get from the MVHR could be problematic if your permeability is relatively high. But having said that, though, there are other benefits as well. MVHR, essentially, it's continuous mechanical ventilation, so from a health point of view, you're getting some benefits from it.
Admittedly,
past 2035 is really primarily dealing with energy efficiency, but there is a need to improve conditions for occupants and control moisture and so on. So you would get some benefits there, and you've got filters in there, you've got particulate filters, you've got pollen filters, and you can also add other filters like NOx filters and so on as well. So
you can have even humidity recovery within that unit as well. Well, it depends on the client, probably, if willing to get the filters F9, let's say, that will get really very good filtration. So the filter is slightly expensive, more than F7, but is really effective in terms of filtration. This is recommended probably for healthcare and this sort of clinic buildings, but also to be installed for domestic buildings, for houses.
Okay, so moving on to the next question, we've got Andrew Craig. Would you use building simulation for retrofit design, or is it more aimed at new builds?
Well, existing buildings, we're referring to the retrofit buildings. Well, simulation is needed, not just recommended. So you need to understand the benefits of having this improvement. Depends on the tool that you are using, but simulation, of course, will give an estimation and a prediction of the future. I gave an example of Wi-Fi, for example. Really good tool to see, and quite accurate tool, because we tested the simulation and tested on site. We monitored this for over 6 months, and saw the results. It gives you really how the moisture behaves within the whole assembly, not just within one element, because there's sensors there, but it gives you a prediction of over 5 years, 10 years, what's going to happen really if you have an insulation inside cavity or an internal ventilation. So it's really good. Simulation tools will help, really. But
I think putting the standard aside for one moment and just looking at the sort of principles of the whole thing, it's about informed design, I feel, and the more tools that you can have at your disposal to inform your design, the better. And, you know, as you say, they are validated, these things. I mean, WFI as an example. I mean, you've got two types of, or two scales of simulation tool that you can use. You've got the whole building stuff, which is, you know, PHPP and dynamic simulation modeling and those kind of things. So things like Design Builder and TAS and IES and so on. And then you've also got the elemental level tools as well, such as WFI and so on. And, you know, they have different uses, but they're all validated. I mean, WFI as an example, Fraunhofer, they validate that as they're continually developing it using physical tests, you know, materials and constructions and so on, and feeding that back in to the software. So they are fairly robust. I mean, they are models, they are simplifications of the real world. So there's always some error margin, but they're a fair representation, I would say, in many cases. I mean, there's lots of factors that go into this, as you know, how accurate is the data that you've got to feed into it on a particular job. You know, what's the competency of the modeler, and you know, what's coming out of it. You know, how is that interpreted and what's done with it. So there are some issues that have to be overcome.
Of course, there is limitation for any tool, really. We can't claim that. Even Design Builder, I have been using Design Builder for years, since 2012, and
yes,
it's quite really powerful tool. The problem with this is quite expensive, but there is limitation. There's limitation even for Design Builder.
Oh yes, yeah,
really, yeah. So I've tried it really.
Well, they are simplifications of the real world out there. So, you know, it's but anyway, so we'll move on to the next question from Tariq Nazar. So it says, as a student, I've struggled to ascertain thermal U values for solid stone walls amongst other materials. Could you recommend calculations, methods, resources, especially since I'm reading there is ambiguity over thermal information from EPCs based on RD-SAP, and even U values for modern materials such as standard brick, updated in 2022. Yeah, I think from that, calculation approaches, softwares, any resources you could recommend there.
Well, my method is always validation. So simple calculation of U value of any element. You can use SAP. So you can use the existing library. You can change that. It's easy really to create a profile with using that. There is a U value calculator, just that one, probably a specific software. What's that software? It's I've used this really. It's U value calculator. It's called it. I have it here, I think, in this software. But my method is to use a equation that simplifies this and validate this result. It's very simple to know the conductivity of each material, create a profile of the wall, of the floor, and thermal conductivity, the thickness. You can validate this if you're not sure with that, and you add that to this, the internal surface resistance and external surface resistance, and that's it. It's really simple to find out, to calculate the U value of a whole assembly of wall or floor or a roof. So validating this, but you will get very similar results if you're using SAP, if you're using PHPP as well. It calculates the U value. So it depends on the conductivity of the material, the thermal conductivity of the material. Let's say within concrete, you get various, like few, depends on the type of the concrete, timber as well. So the material could have various thermal conductivity, but knowing the thickness, knowing the thermal conductivity, and the internal surface resistance and external surface resistance, reciprocal value, we give you the U value, straightforward.
Yes, I mean, in terms of calculation of the U value itself, you know, all those things should be to the British standard and BR 443, which is a BRE document for calculating U values. And you'll find that most U value calculators will be validated against those anyway. So I actually use the BRE U value calculator.
Yeah. Okay.
I've used the Elmhurst one in the past. And so on, and done things manually, but I tend to use the BRE one. But in terms of actually getting the data, I think you've got a couple of challenges with existing buildings. With new builds, it's not so bad because you can get manufacturers' literature, and you'll have the declared values there. You've just got to take into account moisture content in use, because some of them are design values, and some of the issues with what manufacturers are declaring. They will tell you whether it's what type of value they're giving you, but you've got to determine whether you need to add in the in-use moisture content or not. You know, and that can vary in masonry a reasonable amount. Obviously, you've got things like BR 443 that's got some standardized data in there as well. But when you're dealing with existing buildings, I think you've got a couple of challenges. One of them is actually knowing what the existing construction is, in terms of, so if you've got a masonry wall and you say it's solid, is it actually solid? If it's stone, the chances are it's rubble fill. So you'd have like almost like an inner leaf, an outer leaf, and a rubble fill. If it's brickwork, then quite often they weren't entirely solid. They had air paths that run through them, almost like a cavity in the middle where the center joint wasn't filled. A good example of that, if you go to the .gov website and you search for the deck Core Cities project, you will see in that report that there's actually a photograph. It's a photograph that I took actually, and it's you can see the cavity in there. So you can't always open up the existing construction to you know, when you're at the stage where you're calculating the U values. Obviously, as the work goes on, then you can check these things, but initially you can't always do that. So actually ascertaining what's there to start with is quite difficult. The other thing is, what is the thermal conductivity of the material as well, and particularly with historic materials, because they're, you know, bricks won't have been manufactured to a particular standard as they are now, the further you go back, and they vary quite considerably with, you know, the clay that was used, which is usually a local material. There would be local brickworks, and it can have quite a lot of variation, you know, across the country. But also they will be fired differently as well, if they're done in batches. So it can be problematic. You can ascertain these things by test. Obviously, as a student, you're not going to generally do that, and it can be quite difficult doing that in practice as well. So it is a bit of a difficult issue to address. But as long as you make clear what your assumptions were, or what your input data is based on, then
exactly. But I think a few things that helps really. So we used to have a tube camera, if you have seen this. So this catering specialist contractors, they use this a lot. So that small really can go inside that and give you really a good understanding of the situation, if there's cavity or not, how the condition of the cavity. But also you can even measure the moisture content in that surface, internal surface inside the cavity. The other thing is, any material with time, the thermal efficiency will reduce really. So you can't really, there's always a reduction factor of the thermal efficiency of the material with time. So let's say with a 50 year, exactly with the 50 years, then you will have a reduction factor of your value. So
yes, and endoscopes. You just mentioned there an endoscope. They're very useful.
Exactly.
So we'll move on to the next question. This is from Richard Clark. Do you simulate dew point if using internal insulation to check dew point is not just inside the outer brick surface, which will cause brick damage during freezing conditions?
There is a small test. What do you call that test? It's just like I forgot that cube. It's like you put water and see. Just you hold it on the wall against the wall, and you see that how much water will be absorbed inside that brick, and gives you based on that reading. So where is that saturation really point of that surface? Can you remember that, Matthew?
That's a test for absorption, really.
Yeah, but it gives you how much where it's situated really, and how much water went inside that break.
Yeah.
But just measuring the dew point specifically, people are concerned about the condensation more than a dew point. But during the very cold times, that could be a problem really. But I'm not aware of a specific like. But that tool, if you can remember that, Matthew, will really give you the saturation point. So from that graph, a fancy graph, you can see with a dew point really, based on the temperature, external surface temperature, and the saturation.
I mean, I think Richard's right to question this. Absolutely. I think when you're dealing with an existing building, I mean, you should really, with new buildings, also, evaluate or assess the hygrothermal behaviour, and it's particularly important when dealing with an existing building. I would look wider than just a dew point.
But Wi-Fi as well,
at the dew point,
Matthew,
is fine in terms of where condensation is going to occur. But I think you also need to be looking at the other transport mechanisms as well. So in masonry in particular, you've got the suction, which is where
reaction
water's drawn in from the outside from the rain that's falling on it, and then you've got the redistribution. And the problem with that with bricks is that it can, if you're applying IWI, then the mechanism for moisture to evaporate back into the room, which will have existed previously if that space was heated, is being blocked off. And then the other thing, because you put IWI on there as well, obviously the IWI could be breathable and that evaporation route could still happen. But say it wasn't, say it was, a PIR or PUR, and you've got vapor barriers there, you're going to stop that mechanism. The other thing as well is that you're reducing the amount of heat going into the wall, driving moisture outwards that would have occurred previously as well. So you get this potential for moisture to accumulate. So it's not just condensation where moisture's hit the dew point and then condensed. It's also the liquid transport of rain inwards as well that can be a problem. And then obviously, depending on the types of bricks you're using, you've got the potential for frost damage as well if you're getting excessive moisture in the outer layers of the brick. If there's any, depending on the age of the property, you've got any metal ties in there, you've got corrosion of those, potentially timber that's embedded, you've got potential for rot and so on. So yes, I think it's definitely worth looking.
Cement plaster, that's many people, they do this mistake really. So repointing the outer bricks with cement, so lime or gypsum, that will really reduce that risk and get the it's like a biodirectional drying, so drying in and out quickly rather than cement trapping that. But you're right, Matthew.
That's what the joints
exactly.
Does, isn't it? I mean,
the risk of getting really the water or moisture trapped inside the wall or behind the IWI. This is where you need really to think about open cell type of insulation material, so they can dry in and out.
A couple of things I'd point people to as well. There's a project called the Thin Internal Wall Installation Project. That was another government-funded project, so that report's available, and that was looking really at what's the kind of optimum level of insulation to have where you can improve energy efficiency but reduce the risks to the building fabric. The other one, which is the DEEP project, there was a literature review that was released was it last year or the year before, and the final report's due, well, any minute really, but it'll probably be later in the year, I would imagine. Again, that's another government funded project, and that was looking at some of the issues of you know, the existing building fabric and what happens in retrofit, and the different types of retrofit and their impact as well, whether it's whole house or partial, and the different phases you can do it. So moving on to another question.
Just one point here is it's about the minimum thickness of the insulation. BAS 2035 recommended as well that any cavity less than 50 millimeters shouldn't be filled with insulation, so it should be kept air cavity rather than filled with insulation. So it's just shows how thermal efficiency will improve against that issues that could cause this type of insulation. So that will really increase the risk of transferring if the outleaf wall layer that get wet, then will be transferred quickly to that, and will make that water that trapped in that insulation delayed really, so get longer to dry. So that in terms of minimum level of insulation, even BAS 2035 recommended, yeah, this is stated somewhere in that document I read it.
Yeah, well, quite rightly so. A question from Usman Yakub. Is it necessary to do domestic energy assessor training before retrofit assessor training? And what would be the suggested best practice route? Yeah,
you can do the training, but it's a requirement to be qualified as a retrofit assessor to have the DE, the domestic energy assessor. Yeah, you have to be domestic energy assessor to be qualified.
Okay.
Yeah. It's a requirement for the course, really.
Right. Okay. And is that something that you have to have done first, or is it something that's combined with the course?
No, you can do it even during the course, but you won't really be qualified as a retrofit assessor.
So you've done it. Right. Okay.
Unless you do that, the domestic energy assessor course, right?
Right. Okay. So I think we've actually come to the end of the questions there. Tariq responded, just saying thanks, and was going to take a look at what was suggested. Yeah, thank you again, Jamal. Greatly appreciated for you taking the time. We look forward to having you back
for part two
in the future for part two.
Yeah, I'm looking forward to it as well. So more